was a long way on the hoof from North Queensland to the dinner plates of Sydney. What was needed was a port. By 1867, the coastal settlement of Townsville was growing up. Over the years, a port was developed to provide an outlet for local products. Townsville was on the move. Then came the gold boom of the 70s at Ravenswood and Charters Towers. New railways reached out to the new inland centres, bringing more settlers and prospectors. While Townsville thrived as the region's supply and distribution centre for the cattle and mineral industries. Charters Towers became a bustling town of 30,000 people. Their fortunes echoed through the local stock exchange, which worked round the clock, like some of the miners themselves. Millions of ounces of gold were taken from countless holes and creeks. When the gold went, so did the people, leaving only ghosts and legends. While these towns declined, Townsville went on growing. Townsville is today the key commercial centre for North Queensland. Local prosperity is firmly based on a wide range of industries, especially food and mineral processing. Copper, sugar, lead, prawns, the principal wealth of North Queensland is still found either on the hoof or beneath it. The latest mineral discovery is nickel, an essential element for stainless steel. To turn this crude ore into refined nickel called for the construction of a major new Australian enterprise. The Greenvale nickel project includes a nickel cobalt mine at Greenvale and a supporting town. A treatment plant sited north of Townsville and a connecting railway to carry the ore. The heart of the project is the ore treatment plant at Yabulu, 24 kilometres north of Townsville. One of the largest industrial complexes ever built in North Queensland and first of its type in Australia. Nickel ore was first discovered on this cattle property at Greenvale in 1967, following earlier mapping by the Department of Mineral Resources. Metals exploration made the discovery and carried out the initial drilling and fieldwork. Freeport Minerals joined later. Together, they carried out a systematic proving operation over the mineralized area. The deposit stretches out over 300 hectares, is 8 to 20 meters thick, and covered by a thin blanket of overburden. Calculations based on hundreds of drill holes revealed a proven deposit of 40 million tons of ore, averaging 1.57% nickel and 0.12% cobalt. Greenvale ore is lateritic, which means that it's been formed by rock weathering over millions of years, so that the nickel and cobalt is concentrated near the surface to grades 10 times richer than the unweathered parent rock below. The ore is here, but could it be treated? From trenches like this, 2,000 tons were taken for testing in a specially built pilot plant at Freeport Minerals Company Research Center in the United States. Drawing on long experience in the complex treatment of lateritic ore, and after 3 years of testing, Freeport successfully treated the ore by the ammonia leach process, the method now used at Yabulu. From the stockpile, the ore is first dried, then ground, mixed with oil and roasted in multiple hearth furnaces, where the nickel and cobalt is reduced to basic metals. The reduced ore is cooled, then agitated in ammonia solution, which digests the nickel and cobalt, but not unwanted minerals. These remain as solids, which are separated from the product liquor by washing. The useless solids are sent for steam stripping to recover the ammonia before being discharged. The product solution undergoes further treatment to remove the cobalt, a process that yields a valuable nickel-cobalt byproduct. The liquor is now stripped of ammonia, and the nickel precipitated to produce green nickel carbonate. This is heated to increase purity, is then further enriched under a hydrogen atmosphere, hardened and pressed into rondelles, which are 90% pure nickel. After 5.5 years and $10 million spent on feasibility studies, financing and sales agreements, the $260 million project began to take shape. Construction of the whole project was managed for the joint venturers by Queensland Nickel Proprietary Limited, who also designed and supervised construction of the mine, town and railway. They now operate the project for the joint venturers. The Ralph M. Parsons Company, leading international construction specialists, were chosen to design and build the treatment plant. From their headquarters in the United States, a stream of information was soon flowing to their Sydney office and to the site. From Sydney, the hectic task of transforming concepts into thousands of diverse pieces for the plant fell to a host of experts. Each piece had to be designed, made, and transported to the site on time from distant parts of Australia and the world. The constructors were able to shop around the world for the best market value when ordering materials, and follow it up by local supervision. About 80% of the plant was fabricated in Australia, with local industry making a big contribution. A master schedule charts plant site progress from the first to last day of construction.
Make sure that we're going back.
In parallel with mechanical design, civil work at the plant was moving ahead. To supply the large volume of concrete needed for foundations, a batching plant was set up on the site. One of the areas for excavation was around the car dumper, where the ore would be unloaded from the railway. At the same time, the retaining wall for the washing tanks was going up. The tanks will stand on raised foundations behind this wall. The soil is compacted to take heavy weights to come. These foundations will support a 16-story steel building housing the ore roasters, the largest structure of all. A few months later, and foundations for the ore dumper are complete. Ring by ring, the ore roaster rises to dominate the flat skyline of Yabulu. Progress progress after 10 months seemed less evident than the amount of work yet to be done. But within 21 months from now, the plant would be complete. The flow of materials and parts increased with the pace of construction. Pieces designed perhaps 2 years beforehand begin arriving from afar. Meanwhile, work was progressing on the railway, which runs from Yabulu across the coastal plains, then up into the foothills and across the Harvey Range. The track crosses 37 bridges along the 220-kilometer route. Except for the beams for the spans and piles for foundations, the bridges were cast on site. Materials had to be carted by road and finally over rough bush tracks to often difficult sites. Over 600 culverts were put in. Reinforced steel tunnel sections were assembled in cuttings before being filled over. Other tunnels must be blasted through solid granite. Millions of cubic meters of rock were blasted for the cutting and used as fill. After 1.5 years of effort, you could see the shape of things to come. The project was now 50% complete. Many of the larger pieces, especially pressure vessels, can only be made and delivered as complete units, so many heavy lifts are needed. A pipeline will deliver oil from Townsville docks. The oil needs to be heated, so the pipe is insulated with a polyurethane jacket. The reservoir begins to fill with fresh water from the plant's own bore field. Millions of gallons are used daily for cooling equipment and for making up to 500,000 pounds of steam an hour. The power station generates 25,000 kilowatts of electricity, enough for a small town. The auxiliary engine that will start up the power station arrives from Britain and is made ready for commissioning. The end of another day. One of 700 days spent building the plant, which was constructed on a 48-hour-week basis. Most of the men live in nearby caravan parks or in Townsville. By now, the railway was going well and on schedule. As teams got into the swing of things, progress reached 2 kilometers a day. The 1.1 meter gauge rail was laid in 110 meter sections over hardwood eucalypt sleepers. The rail workers lived in camps along the route. Tensioning the bridge across the Burdekin River, the largest river in North Queensland. All bridges and structures are built to withstand pressures arising from swollen rivers during the wet season. Defense against landslides, flooding and washaways will be a continuous job in this tropical zone, especially over the Harvey Range. Mountain roads to the railway were rough at the best of times, but became impassable with the arrival of the wet season, so that no materials could get through. At the plant, progress suffered through the abnormal rains in the second year of construction. And the rains kept on coming. Heavy rains fell over great areas of eastern Australia, bringing tragedy and dislocation. Vital pieces of equipment from diverse locations thousands of miles apart were delayed and stranded. In these conditions, southern companies were not prepared to commit their trucks to go north. At Greenvale, nearly 2,000 millimeters of rain fell in 2 months, 3 times the average. It did heavy damage and cut the only road. Greenvale became isolated for 2 months. With no supplies getting through, all work on the new town and mine was brought to a stop. Greenvale people came to rely on their local air service, their only link with civilization. It could bring in their essentials, but not pieces of plant for the mine. These had to be stored. The weather was one of many problems. To overcome shortage of shipping and manufacturing delays overseas, urgently needed parts were air freighted from Europe and the United States. As the tempo of construction picked up, the scheduled delivery of key items became more critical. One of these complicated sections for the stacker reclaimer was subsequently washed overboard in a cyclone during the voyage to the site. It took 3 months to make a replacement. Whatever the problem or delay, each piece of the jigsaw was somehow got to the project. As conditions improved, work on the project was accelerated using a peak force of 4,000 men. Every type of skilled trade was in high demand, and some acquired their skills on the job to become newly qualified tradesmen. All major areas of the plant were complete. The ore handling area, stacker reclaimers and conveyors, dumper, the ore dryers, the huge roaster building, washing tanks, ammonia recovery area, calciner where the nickel carbonate will be fired, hydrogen and ammonia plant. The chemicals have arrived, and the power station is now on stream. Soon, these pipes will carry chemicals under high pressures and temperatures. Miles of pipes and cables must be tested, controls checked, instruments calibrated in preparation for starting up the plant. Meantime, the ore handling area is cleared in readiness for stockpiling. Now that construction is finished, many of the men and their families will soon be moving on. The project has put a lot of nickel into a lot of pockets, one way or another. Most of it has been spent here in Townsville, one of Australia's most pleasant and fastest growing cities, with its own style of life. To protect this natural beauty, all wastewater from the treatment plant is thoroughly clarified before being discharged well out to sea. Continuous checks of ocean currents and organisms around the plant are carried out by marine scientists. And at the mine, the after effects of mining are also safeguarded. Overburden is replaced and natural growth encouraged. Life has already returned to former test areas. By this time, mine workers and their families were settling into the new town of Greenvale. The town is designed for a population of 500 and has an Olympic-length pool, school and shopping centre and all the essential services. The town's amenities are all within easy walking distance from the residential area, and the landscape has been enhanced by preserving as many native trees as possible. After attending primary school at Greenvale, children receive secondary education either at Charters Towers, linked by rail and road to Greenvale, or Townsville, home of the James Cook University. The loosened ore is scooped up by dragline and piled into heaps. Ore is mined from several areas at once and blended to specification during handling. Ore is loaded into trucks and sent for crushing. Within a few minutes, trucks arrive at the crusher building and dump their loads. A wobbler conveyor separates out the lumps for crushing down to -3 inches. After being crushed, the ore is stockpiled in the ore handling yard. One machine stockpiles, whilst the other reclaims and feeds the belt system to the train loader. As the ore is laid down horizontally and reclaimed vertically, effective blending takes place. Reclaimed ore flows to the train loader. Loading at the rate of 1,000 tonnes an hour, it takes about 5 hours to load a train. 2 trains, 6 days a week, leave Greenvale for the treatment plant, a trip of 220 kilometres. The railway was built by the joint venturers for the Queensland government, who operate it, collecting freights and royalties totalling several $1 million a year. train snakes round the Harvey Range. At the plant, the train enters the ore dumper. The wagons are pushed into the dumper and remain attached while being tipped. At the rate of 2,000 tons an hour, ore moves to the stockyard. Ore is handled in the same way as at Greenvale. In just 1 year's operation, the plant will treat 3 million tons, or 50 of these huge stockpiles. From the stockyard, ore is carried up into the rotary dryers. From dryers to the ball mill, from where the powdered ore is